In this video, we're going to look at some basics of percents. The first thing we're going to look at is percents and how do we rewrite those as decimal numbers. Now, please remember that decimals, percents, and fractions all represent parts of a whole. And therefore, we can convert from percents to decimals, from decimals to percents, from percents to fractions, from decimals to fractions, etc. So please make sure that we are good to go, especially with going from percents to decimals. The second thing we're going to look at in this video is the 10% rule, which will help us with the last portion of this, which is estimation with percentages. So the first thing I want to go to is actually just kind of breaking down what the word percent means. The word per, if we were to translate it, one way to think about it is to think of per means divided by. Okay? So, per means divided by. So, if I have miles per gallon, okay, that's how many miles get divided amongst how many gallons are used. Okay? So, it tells us that we're doing division, essentially. And then the word cent, if I break this into pieces, cent translates to 100. Think about words that have cent in them, like century. That is 100 years. If you ride your bicycle for a century, like a century race, that's 100 miles. A centipede has 100 legs, allegedly. And how many cents are there in a dollar? Well, that is 100. So if I think about this word, per cent, we can think of this as meaning divided by 100. So if I were to say 80%, we could think of that as 80 divided by 100 or 80 out of 100. So when I write it like this fraction, this is me saying 80 divided by 100, because fractions like this are just a way of representing division, dividing things into pieces. So 80 divided by 100, you can even do that in your calculator if you needed to, but that gives you 0.8. A good rule of thumb to know is that anytime you divide by 100, that just moves your decimal place, or moves your decimal 2 places to the left. You can practice, you can pick like 20 different numbers and start dividing them by 100 and see that that pattern exists, okay? So essentially, when I take 80% and I'm taking it and rewriting it as a decimal, I'm just taking 80 divided by 100, which moves my decimal, which would be assumed to be at the end, 2 places to the left, which gives me 0.8 or 8/10. Let's look at a few more examples. If I have 45%, we're talking about 45 out of 100, or 45 divided by 100. So I'm dividing 45 divided by 100. That's going to take the decimal on the end of that number and move it over 2 decimal places to the left. Okay, these amounts are equivalent. When you read this decimal, this place value right here is your hundredths. Okay, hundredths. So if I were to read this number properly, we tend to shorten it and say 0.45, but if I were to say this number properly, we would say it as 45 hundredths, which translates directly to that fractional form. So 45% is the same thing as 45 100ths, which is the same thing as 45 hundredths written as a decimal. This pattern continues. This example, we have 136%, which is 136 out of 100, or 136 divided by 100. Whenever we divide by 100, we take our original value. There's a decimal at the end. By dividing by 100, that moves that decimal 2 places to the left. So 136 written as a decimal, 136% written as a decimal would be 1.36, or 1 and 36 hundredths if we say our values correctly. Now, this percentage is greater than 100. It is possible to have percentages that are greater than 100. So if you think about it, anytime we're dealing with like gaining profits, or like let's say I worked 40 hours this week and then next week I worked 50 hours, but my normal was 40 hours, I would be working more than 100% of my usual amount. So 50 out of 40 would be a percentage that is greater than 100%. Okay, here we have a very common value for sales tax in some areas. We have 8.25% or 8 and 25 hundredths percent. To rewrite this as a decimal, we take 8 and 25 hundredths and divide it by 100. When we do that, we get 0.0825. To say that number properly, we would say that that is 825 10,000ths. Okay, but if we were just going to say it casually, we could say 0.0825. The reason why we want to be able to take percentages and rewrite them as decimals is because when we're dealing with problems and we're taking percentages of numerical values, in order to multiply numbers together, they need to be of the same form. So if I want to take 25% of 80, I need to rewrite 25% as a decimal. So let's take a look at the 10% rule and then see how that applies. Okay, 10% rule. When I rewrite 10% as a decimal, remember that would be taking 10 and dividing it by 100. That cancels, I get 1/10, which is the same thing as 0.1. When you take 1/10 times any number, that moves the decimal left by 1. If you don't believe me, take out your scientific calculator and do 0.1 times 20, 0.1 times 35, 0.1 times 82, and test it out and see what happens. You'll see that the decimal that would be assumed to be on the end would move over one place to the left. Now, if you were to do 0.1 times 1.2, that would become 0.12, okay? So anytime you take 10% of a number, okay, of means to multiply, 10% is 0.1, okay, times a number, let's say n, that will move the decimal on this numerical value left by 1. Okay, this rule is super helpful because it gives us kind of a shortcut to solve quick mental math when dealing with percentages. Okay, but first let's try some. 10% of 90? Well, 0.1 times 90 equals 9. So I don't even have to show this work. If I understand that 10% of, which means times, a number just takes this number and moves its decimal one place to the left, we know that that's going to be 9. 10% of 36.2, that's going to be 3.62, or 3 and 62 hundredths. If I know 10% of a number, can I find 20% of a number? Well, hopefully you see that in order to go from 10% to 20%, this just gets doubled. So that policy or principle will follow through. So if I want to find 20% of 30, first thing I can do is I can figure out that 10% of 30 is 3, because we take the decimal place and move it over 1. But to get to 20%, I have to double, so I have to take this and double that. So 20% of 30 is going to be 6. If you want to check me and make sure I'm correct, you can rewrite 20% as a decimal, 0.2. times 30 and check and see what that equals in your calculator. Okay? But we can do that quickly with mental math if we know how to find 10% of a number. Okay, how do I find 5% of 28? Well, 10% of 28 would be 2.8 because we can take the decimal in the end and move it over 1 to the left. So to find 5% of 28, well, 5 is half of 10. So I'm going to take half of 2.8, which would be 1.4. Okay, I just divided 2.8 by 2. So I could say multiply by 1/2, or if that bothers you, because fractions, multiplying by 1/2 is the same thing as dividing by 2. Okay, so we can easily use the 10% rule to find 5% of a number, which means that we can pretty much do any combination to figure out those percentages. Another thing we could do is if we wanted to find 25%, we can find 10%, and then we can find 5%, and we can add 10% plus 10% plus 5% together, and that would give us that percentage, that 25% of whatever number we were looking for. Okay, so how this comes into play is using estimation to figure out each percentage to the nearest whole number. So we can use mental math and things like the rule, the 10% rule to answer these. We can also use some rounding to answer some of the examples below. I'm going to go through these examples kind of quickly, and I'm not going to cover every single one from the guided notes just because I want to honor your time. If you have questions about this, please make sure that you email me. We are going to use mental math to estimate each percentage below to the nearest whole number, which means that we are going to end up rounding. So we're going to round to the nearest whole number, so this is going to be a good review also about rounding. When we want to find 1% of 2,224, we can think of this as 0.01 times the 2,224. This moves the decimal place of this number 2 to the left. So that's going to be 22.24, which rounds to 22. Okay, so that means if I want to find 2% of this value, I can just take this number and double it. Okay, so if you think about this, the exact answer for here would have been 22.24. If I were to double that, that would be 44.48. So still rounding that to the whole number would be 44. Okay, now we know our 10% rule tells us that this result would be 222.4 because the decimal moves one place to the left. And rounded to the nearest whole number, that is actually 222 because my check digit is 4 or less. Okay, so then if I want to find 5% of this, that's going to be half of 10%. So what I'm going to do is I'm going to take 222 and divide it by 2. That would be 111. Okay, so then to find 15% of 2,224, I could take my 10% and my 5% results and add them together. So 222 plus 111 gives me 333. So approximately 333 is my answer for E. Now to do 70% of 2,224, there are several ways I could do this. But one way I might do this is to take my answer for C, okay, which is 222, and 70% is 7 times greater than 10%. So I could take my answer for 10%, which is 222, and multiply it by 7. Well, that gives me 14. 14 plus 1 is 15. Add 1 there. 14 plus 1 is 15. So that's going to be 1,554. Okay. Now, again, these are estimations. They are not perfect answers. If I want to find 100% of any number is actually that number itself, because 100% written as a decimal is just 1. 1 times any number is that number. So that's just going to be 2,224. So 200% of that number, though, would be twice as big. So I'm going to double this number. That gives me 4,448 is 200% of 2,224. I feel like I've been talking in a tongue twister. Anyway, all right, let's look at question number 2. Estimate 15% of $58 to the nearest dollar. So here's what we're going to do. We're going to do 10% of 58, find 5% of 58, and then get those two answers and add them. So 10% of 58 by the 10% rule is going to be 5.8. Pencil, not eraser. Okay, 5% is half of that, or I can divide it by 2. So I'm going to divide that number by 2, which gives me 2.9, and then I can add them up. Okay, now if you think about it, 5.8 plus 2.9, that gives me a 7, carry that, we get 8.7, so rounded to the nearest dollar. This is actually our exact answer. Rounded to the nearest dollar, it would be 9. Okay, the dollar would be the ones place. Our check digit is 5 or greater, so therefore it rounds up to 9. This estimate would be larger than the actual value because we found the actual value here. One thing that you can do with estimation, and we could do this with the same problem, is that we could actually, instead of finding 15% of 58, we could round this up to the nearest 10 first and do 10% of 60 and 5% of 60. So we could round this value to a nicer number and then add them. Okay, so 10% of 60 is 6. 10% to get to 5%, we divide by 2. So I'm going to divide 6 by 2 to get 3. And then we add them together. 6 plus 3 is 9. And again, we see that that is actually larger than the original value. In this problem, when we're estimating 14% of 80, we could find the exact value because we could do 10% of 80. And then we could do 1% of 80, and we could do 5% of 80, and we could do our answers to this one plus this one, and then subtract that 1% to get 14% exactly. But we might want to just round or find an approximation and just say, well, 14% is really close to 15%. So maybe we could find 15% of 80 instead. But again, we're going to use that 10% rule. So 10% of 80 is 8. 5% of 80 would be half of 8, which is 4. And then I could add them together, and that gives me 12. So 12 is actually exactly equal to 15% of 80. So that's a decent estimate, but we know because I found 15% of 80 instead of 14% of 80 that this is larger than the actual value since I found a larger percentage. Now I could find the exact percent or 14% of 80 because I could find out that 1% of 80 is actually equal to 0.8. We're just dividing that by 100. Moves that decimal place 2 places to the left, which would be 0.8. So what I could then do is take 12 and subtract the 0.8 and get 11.2, which is actually the exact answer. You want to check me on it? Do 0.14 times 80 and see what you get. Okay, so we change the percentage to a decimal and then multiply it times our original value. Okay, so what is my estimate to the nearest dollar? Well, my estimate was 12. we use estimations to get an answer that is close to the original answer, okay? Now, a closer guess for 14% would technically be 11, but using our mental math to solve it, it makes sense to go for 15%. Okay, so here we go. Using mental math to calculate each of these percentages, 200% of 532, that just doubles this number, okay? So this number times 2 would be 1,064. 500% of this value would be 5 times 100% of that number, which would multiply that number by 5. So 532 times 5 would be 2,660, okay? 1,000% would be 10 times bigger, so that'd be 5,320, okay? Just multiplying this number times 10. And then 4,000% would be this number times 4, okay? So 5,320 times 4, 0, 8, 12, carry the 1, 21, 21,280, okay? So one thing that is very important is that you have kind of this fluidity with your mental math, and it's very, very helpful if you know your multiplication facts, which might seem like a silly thing to say, but honestly, it goes a long way when you're trying to do this kind of mental math. So here we go. We're going to estimate 300% of 905 to the nearest dollar. First thing I want to do is I want to first round this 905 down, which is not proper rounding, but it is kind of common sense rounding, to $900, okay? If I were to round it to the nearest 10, this would be 910 if I were to proper round it, but we call rounding like this common sense rounding. What is a nice round number that I could get to that won't give me weird decimals that's very close to the original value? So we're going to find 300% of 900. Well, we know that 100% of 900 is equal to 900. So if I want 300%, well, to go from 100 to 300, that's 3 times bigger. So I just have to multiply this times 3. 900 times 3 is 2,700. Okay, so my estimate, do I expect it to be larger or smaller than the actual value? In this case, this is going to be smaller than the actual value. Why? Because I rounded the original value down. I rounded $905 down, which means my estimate will be smaller than the actual value. Okay, what is my estimate to the nearest dollar? 2,700. Okay, so I actually did the math. When I'm explaining it up here, I'm actually doing the math to answer the question for part C. So essentially, this is what we do when we're doing estimation with percentages. When we look at the next examples, we're going to see some percentage changes and percentage increase, percentage decrease, and then we'll see some more examples. So if you feel confident with percentages, I would say that you might not necessarily need to watch the whole video for the next one, and maybe you could have skipped through some of the stuff in this one. But if you needed to brush up on your percentages, hopefully this was helpful. And please look at the next video just to keep track and make sure you know what's going on. Thank you.